Hello, everyone. Welcome to the Bitcoin SV America's virtual meetup. I appreciate you joining us. I have the tall task of filling in for Jimmy Nguyen, who is the expert at this, but I will do my best to fill in his spots. Tonight, you're going to hear from two of my favorite people in the Bitcoin SV space, Xiaohui Liu from sCrypt and Jackson Laskey from Unbounded Enterprises and Unbounded Capital. I'd like to say thank you for joining this. You know, Bitcoin obviously is so global. I have had the pleasure of meeting people from all over the world in the Bitcoin SV ecosystem. But obviously the Americas has a dear place in my heart, and I've met some really incredible people from these meetups across America. And obviously in this time, it's really good to have you all virtually here with us. Want to introduce the speaker, Xiaohui, coming up. He's actually is speaking at DevCon, and he's a brilliant guy. If you haven't checked out his Bitcoin class videos on YouTube, where he speaks with Dr. Wright, I encourage you to do so. I'll give a very quick anecdote. I've told this story a few times because I find it funny. I first met Xiaohui when I was in San Francisco, and there was a Bitcoin SV meetup in San Francisco at the time. And this soft-spoken guy came up and started having a whole conversation with me. And you know, I was like, oh, that's a nice guy. And we parted ways. And then he messaged me later on the internet saying, oh, by the way, I built an entire compiler for Bitcoin script in C++, as if it was like no big deal. And I found that that pretty accurately describes him. He is a very soft-spoken individual, but he's brilliant and also a builder. So I'm going to pass this over to Xiaohui Liu, who is going to talk about Bitcoin smart contracts 2.0. So take it away, Xiaohui.
Hello, everyone. Thanks, Connor, for the very nice words. I also kind of remember when we first met at the BSV Meetup. I think, yeah, that's why one of the reasons we're holding this meetup. I mean, because of the COVID thing, everybody is staying home and stuff. So I'm hoping we can, someday we can do a face-to-face meetup again very soon. And should I bring up the slides? Oh, okay, thank you. And thanks for everybody for joining, and thanks for Bitcoin Association and Connor and Laura for inviting me here. Today I'm going to very excited to talk about this topic, which I named the Bitcoin Smart Contract 2.0. So basically, for people who don't know about sCrypt, basically we are like it's almost equivalent of Solidity on Ethereum, or you can think of it as like a JavaScript, but on top of Bitcoin script. So when you write a Bitcoin smart contract, you don't have to know anything about the underlying Bitcoin script. As many of you know, it's kind of esoteric and it's very assembly code-like. So fortunately, we have sCrypt now, so you don't have to know any script. So today, I'm going to talk about this, which I call it 2.0. So before I talk about that, I think I briefly mentioned about what is a smart contract and what is 1.0 so far, and why do we think it's a big deal to have 2.0. So let's just walk through this one example. I think a lot of cryptography would like to use the favorite couple here, Alice and Bob. Alice on the left and Bob on the right. We will use this we'll use this couple throughout the talk. So for example, you want to have a fair game. Let's say they want to, after some drinks or play some poker or whatever, they are tired and now they want to just play some very simple game. To use flip a coin, right? This is as simple as you can. So whoever, Alice is flipping it and Bob has to guess which side it lands on. If it's head, basically Bob wins and he takes some money. Otherwise, Alice wins and Alice takes Bob's money. So this is a very, familiar game to anybody, since childhood. So it's very easy to do. Whenever you have a buddy, you can just grab and just flip a coin, as long as you can find a coin. That's great, right? When you're face to face, it's very easy to do, very straightforward. Okay. So let's say instead of Alice and Bob now doing the face-to-face, as a lot of people, we are working from home and we're not in office and we're not even physically, present in a lot of occasions in this special period of history. So a lot of times, especially now we have the internet, we have a lot of business conducted over the internet, over long distance. So how would an easy game like a coin toss played over the internet? So turns out you need so-called a trusted third party, which I denoted as a trend here. So basically, because these two people are not at the same place, so it's not easy, to just flip a coin and then because there are two issues. One, you don't know whoever is flipping the coin. You don't know. You cannot physically check the coin, right? You don't know whether it's a fair coin. Even if you can check the coin physically, you don't know whether the tossing is purely random. It's hard to know this over the internet, right? And even now you have Zoom. You may argue you can do it pretty reliably, but the last obstacle, another big issue is you cannot enforce it, right? Basically, whoever wins, for example, would do this coin toss over the Zoom link. But if you flip, first even we can agree on the results, but there's no way I can make sure you pay me the money, right? If you lose, there's no way. So what we have is usually a trust third party, which I denoted as a kind of like a judge logo here. So what happened here is Alice and Bob, before they want to do this game, they both deposit the payment, some deposit, into this trusted third party. And then they also tell the judge I use the variable x and y here. Basically, you can think of it as a Boolean variable. One means 1 is head and 0 is tail. So both the Alice can say, Bob can say, I'm committed to y. That's my guess. And Alice is going to make a flip. You can represent as another Boolean variable x, and they both give it to trend. In this case, it's the trusted third party. So if x equal to y, that means Bob correctly guessed the outcome. So he's going to give Alice money to Bob. And if y is not correct, and then Alice will take the money of Bob. So in this case, we need a trusted third party. So this sounds good so far, right? So, but there are some issues. For example, one, right? Of course, we need to trust trend. I mean, but he can. There's nothing stop him from, going rogue. He can take the money both from Alice and Bob. He just disappeared, right? That's one way. And also, the whole process is not transparent, right? We don't know whether y is equal to x or not. It's just we have to trust whatever trend is telling us. So that's a part. That's a very good example when the smart contract comes into play. So let's go to how do we do it in a smart contract way. So basically, instead you can see this is very similar to the previous slide, but the only major difference is instead of have a trust third party in between as trend. So here we have the Bitcoin network. So you can use you can think about this great picture here, which is a fully connected Bitcoin network. So it acts as the judge here, and because of the Bitcoin's design, so it's very, very hard, or actually practically impossible. If you're doing low value betting, you can pretty much trust that the Bitcoin network is always doing its job. So one thing is it's transparent. Now you can definitely know whether x and y are equal. So you can trust whoever wins. The result is public. You can trust. And second, you can never run away, right? The Bitcoin network, if you can lock into the script, into the contract, then basically you have for people who have been into Bitcoin for a little bit while, you probably heard about this term called UTXO. So smart contract pretty much means the script size. the script part that's within each individual UTXO. So in this case, how do we design a contract that achieves fair, that simulate physical coin toss? So basically, you have a contract that locks up the H here is a hash. Basically, when it's set up, the game is being set up, the Alice and Bob, they're going to exchange hashes of their guess between each other, which I think the previous thing we show is X and Y. So before this, they hash it and share it with each other. So by the end of the setup, both of them know each other's hash of the secret. I think here for simplification, we just use it 0 and 1. I think in reality, because you don't want people to just hash just two possibilities. So in reality, you will have longer values. But for now, for simplicity, let's just assume X and Y either 0 or 1. So after they exchange these hashes, and they're going to deploy it into a contract. In this case, basically they will specify a UTXO that can only be spent if in two cases. One is if X equal to Y, that means Bob wins. So Bob can sign a signature and take the both of the deposits. Otherwise, Alice wins and she can sign this and take the coins. So this is a great approach to use smart contract for what a smart contract is for. Basically, whenever you want to conduct some transaction, very likely is over a long distance or over the internet, and you don't trust the other party, and you want to, and that's either too costly to find a trusted third party to help you, like an escrow or lawyer or agent, or sometimes such service does not exist. So that's when it's a good idea to use a smart contract, because the only assumption here is the Bitcoin network is honest, and because when you Bitcoin, so a lot of times you can, unless it's you are betting against using $1 billion, you can use zero confirmation, and you can always rely on the trustless nature of a Bitcoin network. So now we talk about the so-called Bitcoin smart contract 1.0. Let's go dive into what is I call 2.0. So in 1.0, I just mentioned every logic, the business logic, for example, the coin flip, this contract, everything eventually ends up into a Bitcoin script. It's locked up in UTXO. Everything, the logic, every part of it is validated by the miners on chain. So that's a key difference when we go to 1.0 to the next concept of 2.0. So why do we need 2.0? I think one example would be here. What's the issue for this example? So after Alice and Bob exchange these hashes, and then they decide to reveal the pre-image, right? They want to know what X and Y is. They plug in the contract, and whoever wins, it wins. But you can, it suffers from the so-called DOS attack, denial of service. For example, if after Alice plugging his number, Bob may find out, Alice is using 1, and I'm guessing 0. So I fail, right? So I lose. If I plug in my Y, I will fail. But in this case, Bob has strong incentive to just abort and just never play along. In this case, he cannot get his money back, and for Alice, he can also his funds is locked up. He cannot get it back. She cannot get it back, right? So that's something very likely to happen in practice. So we want to stop this kind of attack. So how do we do that? We introduce a scheme we call the timed commitment. I think this looks a little bit complex, but let's just walk through this. It's actually very simple. So for here, I draw so-called Bitcoin transactions. Mostly consists of 3 components: the inputs and the outputs. And in some of them, you can see a little bit of a component on the sideways. So this is actually the time lock. So basically, Bitcoin transaction, besides the input outputs, you can also have a a timer. Basically, this says before this time is reached, this transaction cannot become valid and become mined on the Bitcoin network. So think about it's the earliest time that a transaction can become valid on the Bitcoin network. So in this case, we have how do we force a party to reveal its secret value? In this case, X and Y. So we can say, oh, if it's Alice, you can just deposit some some amount into this contract called timed commitment. So how does he get her deposit back? It can happen two ways. One is Alice can reveal, in this case, open. I think we call it announce here. Basically, this is the X here. Alice can, before a time T, Alice can open her X and sign it to take her deposit back. In this case, right, once you take the deposit back, you have to reveal the X. So Bob, who is monitoring the Bitcoin network, can know the X, and now he knows the secret of Alice. So, but here's the key part. You also create another transaction, which is transaction 2 here. Alice pre-signs it with his own signature, such that only after time T, some deadline have passed, then Bob can take Alice's deposit after time T. So the workflow here is after Alice create a transaction 0 and then signs transaction 2 as a partial signature. So we can give it to Bob because there's a time lock here, so Bob cannot redeem it immediately. He has to wait till time T has elapsed. Same for, you can imagine this is not this works symmetrically, right? So Alice can deposit some money, which she has to take. Only way she can take it back is to expose her X, and same for Bob, right? Bob can also make the commitment with his Y value, and before time T, he has to reveal his Y to take the coins. So the key point here, this is very different from the so-called contract 1.0. In which sense? Because when Alice hands Bob transaction 2, it can be off-chain, right? Peer-to-peer. So he's going to validate that Alice's signature is actually correct. So this part is done off-chain. It's not run by miners. So here's the key part. So after we have this primitive, we call it time commitment. How do we conduct a very secure coin toss here? So basically, this is the idea of 2.0. So what's the high-level idea? So in 1.0, everything is validated by the miners, its own chain, is in the form of script, right? So here, it also can have an optional keyword here. Optional, you can optionally have an off-chain part as well, which is also represented in Bitcoin script, but is validated by peers off-chain. So this part does not have to be involved in miners. So for example, again, we have different transactions. So if you look at all these transactions circled in red, so basically this is the old 1.0 coin toss contract. You can see, so Alice and Bob, I think this is maybe a little bit small, but you can follow me here. Basically, this Alice gets some money, Bob gets some money, they deposit into the coin toss contract, and then they both reveal the X and Y. Whoever wins can sign and then take the coins. As we mentioned earlier, this can suffer from the so-called DOS attack. So basically, the losing part, they can choose to refuse to reveal the X and Y's. So that's why we add 2 commitments into here, timed commitments we just talked about earlier, that force each party to reveal the X and Y's. So once we have the X and Y's here, we can plug in. Definitely, we can plug in and then take the coins. So the smart contract 2.0 is you can think of it as a generalized concept of smart contract. So basically, you cannot 100% prevent Alice or Bob from not revealing the X and Y's, but you can ensure if somebody is not cooperating, is not following the contract, the coin toss contract, at least he will be financially penalized. And the other party who is behaving honestly, follow the contract, the protocol, he will get compensated. So for example, you can bet, let's say 1 Bitcoin, so you have a deposit of 2 Bitcoins, right? So if you are rational, or if you are Bob, you win, but as it does not reveal the X, you can, instead of getting 1 Bitcoin back, win 1 Bitcoin, you actually can take at least 2 Bitcoins as a deposit. So you will always win if you actually wins and you are behaving honestly. So the key part here, what differentiates 2.0 from 1.0 is the fact, as we mentioned earlier, a lot of these places, these so-called contract transactions, they are validated off-chain. For example, the transaction 2 we showed earlier, basically you can when Alice hands transaction 2 to Bob with her pre-signed signature, Bob can validate off-chain. And a lot of times, because of the UTXO model, you don't have to, these 2 transactions at most, if we go back to the original time commitment, you can see at most one of the transaction 1 and 2 can end up on chain and being validated by miners, because this is only one unique UTXO. You cannot double spend. So this ensures even it's a validated off-chain. I think that's not the surprising part. The surprising part is even part of it is done off-chain, but if you look at the whole protocol, you can think of another generalized contract. It still maintains the trustless nature, meaning you only have to trust the Bitcoin network. You don't have to trust any other party. Like either Alice doesn't have to trust Bob, or there's no Trent, which is just as a third party here. So you may wonder, okay, now you show me one example of a so-called 2.0, where you can have an optional part where you do some of the validation of the contract off-chain, and you can still maintain the trustless nature. Why do you want to do it this way? There are actually a lot of benefits you can have by implement some of the contracts in a 2.0 fashion. Why? For example, we give one example here. So remember earlier, so each transaction is represented by inputs on the top and outputs at the bottom. So you can think of, you can imagine, instead of just create one level of off-chain transactions and hold it offline, you can think of, if the contract is complex enough, you can imagine you can go many levels deep down, right? So imagine if you Alice and Bob decide, depending on who's revealing what, you can say another party. You have let's say Charlie, right? You can keep this contract, keep these chain transactions, keep creating them off chain. So you may end up with something like a tree, or even in general, it's called a graph, or DAG, directed acyclic graph. So you can think of all these transactions together consists of the whole contract. But the amazing thing here, as you mentioned, as we also hinted earlier, because the UTXO can only be spent once. So imagine, even if you had DAG or a tree in this case, eventually you only have one path that can be settled on chain, because otherwise that means some UTXO is double spent, which is impossible, right? So the time complexity in this case, not time complexity, the number of transactions, which is directly proportional to a transaction cost. The cost you run in this contract, you just, let's say we have n nodes here in this graph, in this tree. So originally, if you don't use if you don't do 2.0, you end up having to spend. You have to broadcast all these n transactions. So now, if you have a 2.0, because now at the most one pass is going to be eventually end up on chain. So it's going to be a log event. So we have a huge reduction from in terms of computer science jargon, it's a big old notation, but you can think of instead of broadcasting n transactions and have a huge cost of running this contract, now you are reducing it to like a log event, which is huge, especially if the n becomes, let's say your n becomes a million transaction. Instead of 1 million, you probably only have to broadcast like, let's say 20 transactions. That's a huge reduction, right? So it's worth noting, and also because in this case, most of the transactions, which consists of the whole full picture of the contract, is held off-chain. It's never settled or exposed on the public blockchain. So it also adds a lot of privacy, because if you only look at one pass, it's very unlikely, or a lot of cases it's impossible to figure out what the whole contract is about. Maybe you are doing coin toss, or maybe you are doing some kind of like a secure lottery, or maybe you are doing some kind of like a any other type of games. You don't know, right? So because you only have one pass, that's only eventually settled on chain. So that also means you have extreme privacy as well. So we just talk about if you're using 2.0 in this case, you end up hugely more efficient and private than you just run a Bitcoin script, which is a smart contract 1.0. And as a great note here, we can think of you could imagine this is very easy to implement in Bitcoin, thanks to the UTXO model, because it naturally leads to this off-chain transaction that's chained together, and eventually only one pass is going to settle on chain, and it's going to be very hard, if not impossible, if you're imagine trying to do this kind of a off-chain and on-chain mix the transaction or contracts together. I haven't figured out a way to do this in account model, because account model you cannot have separate branches like in this tree, right? So maybe my guess is when Satoshi designed this Bitcoin to handle all kinds of smart contract in the very beginning, before some other people disabled all the scripting capability, that's one consideration why he's using another reason to use a UTXO model is much more efficient and private. And it's not something I haven't figured out a way to do this in account model. So if you guys who's listening knows how to do this in some kind of account model based blockchain, yeah, let me know. So what's next? I think it's I just showed you one example how to do this so-called smart contract 2.0 in Bitcoin using coin toss. We also have a lot of other examples. So basically, you can also do Coinbase with. We mentioned how you do fair coin toss with some deposit, right? Using time commitment. But it turns out you can also do this without any deposit at all. So you can also have the so-called cooperative contracts. That basically, no matter how complex your contract is, you can always leave a backdoor. So if all the parties agree, they can just jointly sign and release the funds. You don't have to run the super complex contract. But this also involves off-chain coordination between all the parties. So, and also we show some examples how do you make sure you can review all the inputs and exchange all the secret inputs in the so-called multi-party computation. And we have a lot more coming down in the pipeline. So stay tuned. So thanks everyone. That's pretty much a wrap up our talk. You can find all our information on this website based in sCrypt.io, and all the examples, including the articles and the code. Everything is runnable code. So you can also go to sCrypt.io and click on our Medium post. You can see all the codes and explanation there. Okay, thanks everyone.
Thank you, Xiaohui. Real quick, we have time for maybe one question. So if you could keep your video on, we'll ask one question for you. You had mentioned smart contracts 2.0, and we were talking about why the Bitcoin UTXO-based model was better than the Ethereum account-based model. But the question was more generically, what are the key differences from a development perspective using Bitcoin script or a compiler like sCrypt and using Ethereum Solidity, and what are the pros and cons to both?
Okay, first of all, UTXO, I think pros, of course, is think about UTXO is each UTXO is independent from any other UTXO, right? Because if using programmers terminology, it's called a functional. So basically, each one is like a mathematical function, right? You can do a square, or you can do a, let's say, cubic function, right? Doesn't matter when you write, how you write, parallelize. So that means you can massively parallelize everything because each UTXO is independent from any other UTXO. So that's number one. Versus the account model, which is Ethereum and many other blockchains using. The disadvantage is you have a global state, right? So think about whenever you need to mutate anything, you have to lock the whole thing, then you do it one after the other. You cannot inherently, you can only serialize it. So that completely changed the picture, right? So with UTXO, you can do all the UTXOs independently. You can have as many calls as possible. So that's a massive parallelization I can think of. So versus Ethereum and other account model, because there's a global state, so every time you mutate, you have to log it, and when you finish, you run it again. You do the next one. So it's everything is serialized. So that's number one. Number two is we just mentioned the 2.0. It basically it becomes a natural advantage of a UTXO model, because then you can create a lot of off-chain transactions, which is only held locally. You don't have to, the miners may never see it, because you just see my example. If you have one UTXO, you may branch out, maybe 3 transactions, 4, and then 5 levels, right? Maybe in total you create 100 transactions. That's part of your generalized contracts. But you cannot, you don't have to, when they settle, there's only one pass given, right? For example, Alice wins or Bob wins, depending on who wins. You only have one chain that's settled on chain. So that gives you privacy as much, and also scalability, right? Because instead of sending 100 transactions, everything on chain, everybody runs it, you only have to send like, let's say 5, right? So that's another advantage. I think if I'm being honest, we only have to we talk about the cons of a Bitcoin script, and also for sCrypt, is because for so long the script has been intentionally or unintentionally disabled. So it's just that we have a late start. But I think from a technical perspective and also from an economic perspective, it's just far superior technology. I think I'm very confident it's just a matter of time we can flip the network effect they're having. And thanks, now we have the sCrypt, which is high-level language. You can think about it's almost as you are coding in Solidity. I think that's our design philosophy. We try to make the appearance and the developer experience as similar as what you have already learned. You don't have to learn something fundamentally new. So that's also a big advantage. And lastly, I think I want to emphasize there's a misconception out there. I don't know, is somebody spreading rumor intentional or what, because they don't understand. The Bitcoin script is actually Turing complete. And this is not something disputable or you have to read papers. We have a live transaction on mainnet that can demonstrate using game of life. And we can also using other automata, anything you can think about. Any computation you can do is a Turing complete. That means any computation you can do on any other chain or off chain or any powerful computer. You can also do it on Bitcoin network today. So that hopefully clarifies some little bit.
Very good. Well, thank you. Well, I appreciate people like you making it easier to catch up to things like Ethereum and making it easier to build on Bitcoin. So with that, I'm going to move on to the next speaker, Jackson Laskey. He is the CEO of Unbounded Enterprises, and he's going to talk about Unbounded Enterprises development tools. And I'm going to pass this over to you, Jackson. Thank you.
Well, thank you guys very much for joining me. And I see a bunch of familiar faces in the attendees list. It's kind of awesome that I know, I think, over half of you guys. So really appreciate your time tonight. I want to talk about a couple high-level things and then talk about some of the stuff that we're doing at Unbounded Enterprise and how developers in particular can get involved with what we're doing. So real quick, I'll start simple. What is Unbounded Enterprise? Some of you guys haven't heard much from us since we actually announced back at CoinGeek New York. When we announced Unbounded Enterprise, we talked about our mission and our goal. Our mission was making adoption simple, and our goal was to become a transaction processor. Now, I'm happy to say that neither of those things have changed, but our path has really come into focus over the intervening months. And that path is advancing Bitcoin through gaming, and specifically video games, much more so than gambling apps. I do have a background as a poker player, and I would love to see a Bitcoin-powered poker site someday, or at least a really high-end Bitcoin-powered poker site. Maybe Calvin can do that. But what we're focused on at Unbounded Enterprise is pushing forward adoption and making new ways of both individual developers, small companies, and ultimately enterprises to get involved in Bitcoin and really push Bitcoin technology forward in general through the gaming vertical. So I've noticed over the past few months, what I see is Bitcoin sort of starting to move towards being a gaming-oriented ecosystem. And I wanted to just touch on that briefly because I think that this is, in a lot of ways, a really positive development. Now, I've been in Bitcoin SV for the past 2 years. I've had really many conversations with businesses, enterprises of various sizes about the ways that they could use Bitcoin in the present, could use Bitcoin in the future. And while the potential is enormous, there's a number of challenges to adoption today. One of these is sort of the unprovenness of the ecosystem. Even though we have amazing potential, we talk a game that's bigger than what we've actually shown. I would sort of put this as we talk in terabytes, we live in megabytes, and sometimes we actually struggle with gigabytes. But that's okay. We're going to get there. But it can be a challenge when you're trying to get enterprises to build on top of Bitcoin today. Another challenge is the popularity of BSV, which is not always stellar. The size of companies in the ecosystem. We have a few really big companies which have had, I think, more success driving enterprise adoption. But I think a lot of companies in the space they're still in that sort of maybe just 1 to 10 person size, and that's a tough sell. And then one other thing that is a challenge that Bitcoin faces today is we have an extremely broad focus as an ecosystem. If you guys were here at the beginning of this presentation, you heard Connor talk about how Bitcoin can be used, in all kinds of different verticals, all sorts of applications. Essentially, we're trying to take over the internet. So it's a very broad value proposition. That's great long term, but in the short term, I think that there can be a consequence, which is that, even though we are a talented and growing community, there's a diffusion of talent, which I think can work against us to a degree. So I see the convergence on gaming as a solution to a lot of these challenges and something that can really help accelerate the advancement and adoption of Bitcoin. The provenness element, this provenness, popularity, the size of companies, this really isn't as important to the gaming audience. What matters is whether or not we can make compelling games. And by utilizing micropayments and smart digital property, as well as I'm sure other things in the future, I think we can make unique and compelling games today with Bitcoin that can drive real adoption. Now, I give a lot of credit to, in addition to FIX, which has sort of been leading this charge for a long time, I think Haste and Handcash Connect really kind of lit the imagination of the industry. Haste with their leaderboard system, and Handcash Connect, which the launch of Handcash Connect, I think, really facilitated Haste. Credit as well to RelayX and Run, who I think, along with FIX, have really sort of led a convergence of talent around the Run ecosystem. And today we see FIX, Twetch with their recent taco game, Run and a number of games building on top of Run, Unbounded Enterprise now, as well as Haste and Peer Game, and a number of other initiatives I'm aware of that haven't been announced yet, but are extremely exciting. We're really seeing Bitcoin starting to become game coin. And I think some of the benefits of this are that these companies are going to be able to really share in the cost and effort of educating the market. We're going to be able to provide a more robust experience to these gamers, and we can really concentrate our innovation and our development of best practices in one area where multiple companies can really improve at a rapid rate by focusing on the same vertical. And I think that by driving adoption in one vertical, it's really going to help prove the value proposition of Bitcoin. It's going to help prove the scalability of Bitcoin, and it's going to help really bring a lot of attention and users to the space that'll make all of our future efforts much more fruitful. So with that, I want to talk about specifically what we're doing at Unbounded Enterprise, which I'm extremely excited about. And that is Nifty Jigs. So I think a lot of you guys have probably seen some of what we've shared about Nifty Jigs, but I wanted to just take this opportunity to talk about what are Nifty Jigs. And then in a second, I'm actually going to preview the Nifty Jigs app. So I won't do too much telling, I'll do some showing. But first, let me answer this question. What are Nifty Jigs? So Nifty Jigs are a platform for making games and adding a new dimension to existing games. And Nifty Jigs are NFTs. So the platform is all centered around these NFTs, which are Nifty Jigs. I think really the best way of understanding Nifty Jigs is through an analogy. So I think Nifty Jigs are actually very similar to platforms like Xbox and PlayStation. Xbox and PlayStation are both platforms for building games and distribution channels for games. And Nifty Jigs is really the exact same thing. Xbox and PlayStation both provide developer tools and an ecosystem that makes it easier to create really compelling games. Nifty Jigs is the same thing. Of course, there are differences. Xbox and PlayStation are both hardware. Nifty Jigs is a set of NFTs. They both come with various developer tools. But I think that one of the most important differences, which really helps to understand what Nifty Jigs are useful for, is to consider that Xbox and PlayStation they're really interchangeable units. Every Xbox is the same as every other Xbox, which means that if you combine Halo plus Xbox, you always get the same experience, or at least you always start at the same place. With Nifty Jigs, that's not the case. Each Nifty Jig is unique, which means that every set of Nifty Jigs is also unique. And what that makes it possible to do is it makes it really easy to deliver games to gamers where every game player starts with a unique experience. The first game that we're building on Nifty Jigs is called Hash War. Hash War is a trading card game, which is Bitcoin themed in a really fun way, I think. And like other trading card games, it's really predicated on the idea that every player starts with a different starting point. When you start a match, you have to bring in your own deck, which has it's a unique deck, which comes with different possibilities, different strategic implications, different ways to win. And half the fun is actually constructing that deck, which enables a certain strategy, which you can then execute when the game starts. So Nifty Jigs is a platform and a distribution network for delivering games like a trading card game that each have their own starting point for every individual player. And I think that makes it actually a really powerful distribution channel. Players who have an Xbox are more likely to play an Xbox game. I think players who have Nifty Jigs are going to be much more likely to play a Nifty Jigs game than other types of games, and even more so because unlike with Xbox, where everyone starts with the same experience, with Nifty Jigs, everyone actually starts with a whole unique and customized experience. And I think that it's a really exciting experiment in gaming that I'm happy to be a part of. So enough telling, let me show you guys some of what we've been working on. I'm going to be showing you guys slides from our mock-up. Unfortunately, I can't show you through like our clickable mock-up or our current developer model, but I think this will get the idea across pretty well. So this is the Nifty Jigs dashboard. This is where you can see some basics like how many jigs do you have, what's your BSV balance. Right now, we have a window where you can launch Hash War. the trading card game that we're building. In the future, this might look more like an app directory. And here's our nifty announcements, a place where things could happen like every time a new game gets launched on niftyjigs, there's an announcement and you can look at your niftyjigs and you can see, hey, what are all my niftyjigs in this new game that just got released? This is the jig, a place where you can look at your jigs. Every jig is unique because it has a unique serial number. And this is kind of a boring way of looking at your jigs. It's not very exciting because all you see is the number. So what we can do is we can look at it in the context of a specific game. So here are all of these same jigs, but in the context of hash war, same serial numbers. And the way hash war works is every serial number maps to a specific card in hash war. So we can see that serial number 9 is Craig's ransomware, that card in hash war. Serial number 72 is QuickScan, so on, so on. We can even get a nice close-up view of each jig. So we can take a look at Craig's ransomware. We get the 3D model that everyone's come to know and love from the NFT space, and something that Twitch does extremely well with their chicken nugget NFTs and whatnot. You can also see some game-specific information. You can list the nifty jig on the nifty jig marketplace. You can transfer the jig. You can give it a nickname. This happens to be our UX designer's favorite card. It's very nice. And so this is your place where you can really get to know your jigs. Now, if you're interested in more than just the jigs that you own, you can use the jig catalog, where you can explore the entire universe of nifty jigs. Here we're looking at nifty jigs in the context of hash war, but we could flip that context and look at nifty jigs as BSV cards. BSV cards is the name that we gave to some of the card designs that have been released recently by Diego on Twitter. I'm sure a lot of you guys have seen these. We got his permission to use these, and this is what they might look like if they were issued on top of nifty jigs. Every nifty jig would be one of these BSV cards. And potentially what could happen is someone else, not necessarily Diego himself, could actually build a game around these cards or build multiple games around these cards. And that's part of the power of nifty jigs. They really highlight the interoperability that's possible with Bitcoin. Here's the jig store. We can see here that we're searching for jigs which are the Craig's ransomware card in hash war. They all have different prices, and that makes sense because just because 2 jigs are the same card in hash war doesn't mean that they're the same card in another game like BSV cards. And also these have different serial numbers. People maybe value serial number 9 higher just because it's kind of rare to have a 1-digit serial number. This is a dynamic that we've seen in other parts of the BSV ecosystem. So if you want to, buy a card that's both Craig's ransomware and Twitch as BSV cards, you can do that with our advanced filters. The rest of it is pretty straightforward. We have our wallet where you can see your balance, your transaction history, and a little social function where you can message other nifty jig players and you can do things like coordinate trades. For example, in the jig catalog, if someone has made their jigs public, you'll be able to initiate a conversation with them and say, hey, I saw that you have this jig. I really got to have this jig. Let's set up a trade or set up a purchase. So that's the Nifty Jigs app in a nutshell. And I'm really excited to announce that there's a way of getting involved with Nifty Jigs today if you're a developer. For all the details, definitely head to niftyjigs.com/developers. But I'll give you some of the sneak preview here. What we're announcing is our Game Masters program. So the Game Masters program is really an opportunity for us at Unbounded Enterprise to work side by side the first generation of games building on top of Nifty Jigs to really make sure that everything we're building from an API standpoint, an SDK standpoint, really fits the needs of the games that are building on top of Nifty Jigs, being able to work side by side with our customers. We're currently accepting applications to our summer 2021 Game Masters program. We're going to accept 5 kick-ass game developers into the program. Definitely encourage you guys to apply, and we'll help you with your application. We want the best possible applications. And the program costs nothing, and it comes with a bunch of really cool perks. So first of all, you're going to be one of the first games built on NiftyJigs. You're going to get early access to our API and our SDK. You'll get support from our team in development, UI, UX design, game design, as well as marketing strategy. Of course, we'll publicize your game. We'll feature you in the NiftyJigs app. But perhaps most importantly, we'll also give you a revenue share on all NiftyJigs sales. You'll become an owner in the ecosystem that you're helping to create. And we save the best for last. We'll give you cash to help you get started. So definitely, I won't be saying this elsewhere, but I definitely want to give a nod to folks who are kind of BSV native. We really want to prioritize people who are already in the ecosystem and are looking to really give their all to help drive Bitcoin adoption by creating games. I think it's a really great way to get started if you're a developer looking for a way to get into the ecosystem. As I mentioned at the beginning of the presentation, I really see Bitcoin now starting to congregate around the gaming industry. And so I think that this is really a fantastic opportunity to get involved. And I'm looking forward to working with some of you and helping you build an amazing game using NiftyJigs. That's all I got.
Thank you, Jackson. Just a couple questions for you here. Could you explain what a jig is and why NiftyJigs?
Yeah, so we actually, we started out, we were going to call it Nifty Cards, but we realized that these could be more than cards in a trading card game, much more. And so we wanted to use a term that really implied the possibilities that come from NiftyJigs. And so we borrowed a term jig from Run. Run is a token, or I would call it like a smart digital object platform, but they're a token protocol on top of Bitcoin. And everything done through Run is done through these objects, which are called jigs. And so because NiftyJigs sort of inherits the functionality of Run, we decided to also borrow the name jigs. And that's how NiftyJigs was born.
Very good. And then I'll ask just one more brief question here. But so someone's asking, if I make a game with NiftyJigs cards, are they all available in some kind of, is there a marketplace? Is it an app marketplace? Or how can I explore other games built on NiftyJigs?
Yeah, so through our app, players will be able to explore the NiftyJigs ecosystem. This includes being able to see what are all the games that have created a game or an integration for NiftyJigs, as well as look at individual jigs and say, all right, what are these inside of these different games? We're trying to really focus on creating a UI UX that makes that kind of exploration as fun and simple as possible. That being said, we haven't answered all these questions. And so this is part of what the Game Masters program is all about. It's about working with people who want to create a game. They're excited about the possibilities with NiftyJigs. And we can figure some of these things out together and create an experience that not only helps to really highlight the game that you've developed, but also other games in the future that can piggyback off of the success and network that you've helped to create.
Very good. Thank you. I'll ask this one question. Someone's asking, what makes it an NFT 2.0 specifically? Could you answer that question real quick?
Oh, yeah, sure. So NFT 2.0 is something just for fun that we came up with to sort of describe how NiftyJigs are kind of a different type of NFT than other NFTs that have existed in the past. So NFT 1.0 are NFTs where the NFT is kind of the end in itself. So this would be like NFT art, where the NFT is just an art piece. So NFT 2.0 is really sort of a NFT that's used to create other NFT 1.0s. So it's an NFT which is sort of a bridge to other NFTs. So you could think of it as like, if NFT 1.0 is a painting, NFT 2.0 is a frame. if NFT 1.0 is like a game item, then NFT 2.0 is sort of like the Xbox of NFT games. And so it's one NFT which can become the foundation of many different NFTs. So maybe it's a little bit arcane, but we thought it was fun.
I love it. Great. Well, thanks, Jackson, and feel free to reach out to, what was the email again? Or I guess you can go back and find it, but get involved in that.
niftyjigs.com/developers. And if you want more information about Unbounded Enterprise generally, unboundedenterprise.io.
Great.
Thanks for having me, Connor. Thank you, guys.
Yeah. Thanks, Jackson. Thank you all very much for joining. It's been an honor to fill in here for Jimmy Nguyen, and I hope to see you all very soon. Thank you.